Alright, Year 11s, let's get you guys set up for your holiday homework. Not forgetting that you've got to finish everything you've been set so far from like chapter 4.1 and 4.2. I'm assuming you're going home and finishing those transformations off, having a go at all those chapters and making sure you know how to go left and right and up and down and turn things upside down and stuff. This is a good chapter for us to practice on. Practice this online remote delivery because it's a small chapter. It's not as important in the whole scheme of things. It's part of the Year 11 course that doesn't fully go through to Year 12. There is some implied knowledge in it, except don't count on seeing too much of it next year. It's about circle graphs, graphs that are circle shaped, because none of our graphs have been circle shaped so far. We've had U shapes, they've been upside down, we've had cubic shapes, we've had hyperbolas and truncuses, no circles. So this is a small chapter dedicated to circle graphs. So what we've got on the screen here is we've got a circle graph. No surprises here. It is a circle. It looks like a circle. It's a circle. When we're dealing with circles, there are only two things that matter. If you're looking at this graph and trying to pick out the things that matter, your first instinct is probably the x-intercept and the y-intercept. But like always in methods, you're wrong. The two things that matter when working with a circle, the x-intercepts and the y-intercepts are incidental. We're not going to go out of our way to measure them. The two things that matter when working with a circle graph, you need the center of it, because you need to know where it starts. Okay, so that's a bit like our turning point or our point of inflection. Find where the middle is. And then the only other thing you need to know is the radius. Okay, because every circle looks the same, right? They're all similar, they're all circle shaped. As long as you know where the middle is and you know how wide it is, and it's always in terms of its radius, not its diameter, its radius, you'll be able to sketch the graph. And then finding x and y intercepts, it's a little bit beyond the scope of Year 11 methods, so we're not going to worry about it unless it's really obvious, like when the circle has a radius at, or a center at 0, 0. So now let's have a look at the equation of the circle. So the equation of the circle is going to be a little bit different than what you've seen before. A basic circle would have x squared, and it would have y squared, all on the same side, right? And that's different. It's not something we've ever seen before. Both of our variables are squared, and they're both on the same side. And if we're talking about something like a unit circle, which has a radius of 1, we'd put this over here. Okay, so that's what the basic equation of a circle is. But if there's a bigger number here, it's going to be a bigger circle, and there's going to be translations, right? The center is not going to be at 0, 0. It's going to be across, it's going to be up, it's going to be down. So then the basic form of the equation is down here. So my x and my y can have numbers added or subtracted to it. We call the side-to-side movement h. We call the up and down movement k. And the radius is r. So if I look at the way this is done, the letter h is going to be added or subtracted to x. Essentially, if there's a number being subtracted, it's going to move it to the left. Oh, sorry, it's going to move it to the right. I think I'm pointing right. And if there's a number added or subtracted to y, it's going to move it up or down. But because both of these things are on this side, because both of these things are in brackets, this is all backwards. So a negative number always moves in positive direction for circles. Okay, so if there's negative 4, it moves across to positive 4 here. If there's negative 4 inside this one, it moves it up 4. What's on the other side is a number. That number's going to be squared. Okay, so if there was like a 4 here, then the radius would be 2, right? If there's a 9 here, the radius would be 3, because 3 squared is 9. Okay, so let's just have a look at that in practice, because I think it'll make more sense once we actually have a go at it. So in this very small chapter on circles, most of the questions you'll see will look like this. The first thing you have to do is write the equation of this circle. They told you where the middle is, so it's across 2 in the positive direction and down at -3. It's got a radius of 5, so we're going to create the equation, then we're going to sketch the graph. I do have this big note here. It's serving two purposes at the moment. You'll see the second purpose soon, but the first reason I've written this here, a circle is not a function, is because you're not allowed to write the equation like this, right? You can't say it's f of x. Okay, circles aren't functions, so we're not going to use function notation for this. We're going to use letter y. But as you've already seen on the previous slide, the letter y and the letter x are in our work. So the basic form of the equation is x take away h squared. Okay, and the letter y has the letter k with it, right? So plus y take away k squared. And on the other side, we're going to have the radius squared. Okay, so it's good to write out the formula for it, because then we can substitute values into it. So the 2, here's my side-to-side movement. It goes here, all right? This is h. The minus 3 is k, right? That's going to go just where k is, and the radius is r, right? So we're going to put these numbers into our equation now and just get it looking good. So all I've got to do is I've got to substitute 2 for h, so I'm going to put 2 there. The k is a little bit more complicated because it's already a negative number. So really, if I think about how the end result's going to look, we'll put it like this, right? I've turned k into a negative 3. Yeah, I've turned h into a 2 and k into a negative 3. On the other side, I've just got to turn r into a 5. And that's going to get squared. Okay. So then our final answer for this, our actual equation, there's nothing to do with this. It's x take 2. And that's squared. Plus, and now all we've got to do here, we can see that a minus minus are there together, and that's positive, right? Taking a minus is a positive. So it's y plus 3. Okay, so this is always backwards. Since it moved down to negative 3, our equation has to have a plus 3 in it. Okay, this one moved across to positive 2, it has to have a negative 2 in it. Put the squared on it, and that equals on this side 25. All right, so knowing your square numbers, if you got given a circle equation, you saw a 25 there, you'd know it has a radius of 5. Okay, so we've written the equation of it. Then we have to sketch the graph. Okay, so the other reason I've got this thing here is it was covering up my graph. Okay, so I've got my set of axes drawn up. I've got my center. My center is across at 2 and down at negative 3. Okay, so you can put a little dot there if you want. But essentially to show this, to show that we have a center and we have a radius, we're going to try and just label the 4 kind of extremities of the circle, the 4 points that line up directly with the center of it. Okay, so this is 5 units up from the center of my circle. Okay, so I'm still across at 2, but I'm 5 units higher than negative 3, so I'm actually up at 2 as well. Okay, we're not worried about labeling the intercepts today, which is good news for you guys. This point here is 5 units to the right, 5 units in the positive x direction. So it's not at 2 anymore, it's at 7. And because it's lined up with the center, it's down at negative 3. This point is 5 units below. So I'm still at 2. But now I'm down at negative 8. And this point is backwards 5 units from 2. So I'm at negative 3 and at negative 3. Okay, so I have an equation built from the information that I was given. Then I can sketch it by finding the center, drawing a nice looking circle, and then labeling the extremities of it. Now, unfortunately for you guys, there is one other type of question you'll have to answer. It's when you're given your x squareds and your y squareds, but you've also got x's and y's. And there's going to be some algebra to be done, right? This question is really just, again, practicing that algebra, getting better at algebra, because it's good to be good at algebra. So because we've got x squareds and x's and y squareds and y's, we're going to have to be kind of factorizing this so we don't have x's all over the place and y's all over the place. Completing the square is our method. I know it's a circle graph. There is no completing the circle method. We're going to complete the square to make circles. So I've listed the steps on the side here. First thing we're going to do is we're going to put all the variables on the left-hand side. So we're going to get anything that has a letter X or the letter Y in it all together on the left-hand side. So I'm going to be taking these 6 X's over here and taking these 8 Y's over here. I'm just going to put all my X's and Y's next to each other because they're going to be our focus one at a time, X and then Y. So I'm and put the minus 6x here. Right, I've moved it over there by taking it. I've still got positive y squared there next. And I'm going to subtract 8y's from the other side. And on this side, I've still got equals 24. Okay, now I'm going to complete the square, but the information you've been given here is that you've got to complete the squares for x and for y. So you've got to do them one at a time. Okay, we're going to be putting numbers in here for x and numbers in here for y, and we're going to be working with them separately because they each need their own set of brackets. We need an x bracket, we need a y bracket. So we know when we complete the square that our focus is on these numbers here. These are the ones that we have to, first of all, divide by 2, and then we have to square as well. So we can sneak a bit of working out for that and put it up in the corner. Right, so I'm going to be going negative 6 divided by 2. This is the number that's going to be part of our factorization, but we also have to take the extra step of squaring it because this is the number that we first add and then subtract in our completing the square process that we've had a bit of a go at. So let's put that in for our x's. So I'm going to start by putting the x squared there, and then the minus 6x. And this is the point where I'm going to complete the square for x. So I'll do this part in red. So we're going to be adding 9. And then to keep our balance, we need to be subtracting 9 as well. All right, and it's worth noting, right, that this here, sorry, that's a bracket. This is the part that will soon be factorizing down into our perfect square, which is kind of the point of completing the square. All right, so we've done that for x. Now we're going to follow the same process for y. So for y, the coefficient of y, not y squared, just y, is negative 8. So I'll be going negative 8 divided by 2. Negative 4. And then we need to square that value to make 16. Okay, so when I factorize, this will be in it, but the 16 is what I'm adding and subtracting into my equation. So let's carry on with this big long line of working out. We have y squared. We have minus 8y. Now it's time to put my 16s in. We'll be adding 16 and subtracting 16. And it's the first 3 components that get factorized into a perfect square, and then we'll worry about these soon. Equals 24. Okay, for this next line of working out, we'll try and do 2 things in one go. We know we've got to factorize down the parts that I put in green brackets, but we don't want this minus 9 and this minus 16 involved. So we're actually going to just send them to the other side. So I'm going to get this 24, I'm going to add 9 to it, and I'm going to add 16 to it. So what we will do is we'll put that over there. 24 plus 9 is 33, and 33 plus 16 is 49. So that side's going to end up being 49, which for the purposes of today's lesson is beautiful. It's a great number because it's a square number. We're going to have a really nice radius on this circle. All we've got to do now is we've got to factorize this down. So the process is factorizing this into x take 3 squared. That was the number that I had up here before for my x's. And it's also, if you're forgetting where it came from going negative 6 divided by 2. And this one will factorize down into y, take away 4 squared. My 4 looks a little bit like a 9, but I'm sure some of you will forgive me for that. I'm sure I can get away with that, right? There's nothing wrong with having a 4 that looks like a 9. So that is the general form of it. It looks like our equation should look, so we can now find the center. Okay, so the center has been defined by this minus 3, this minus 4. All of our translations work backwards for circles, so that means it moved positive 3 side to side, and it moved positive 4 up and down. So the center of this circle has the coordinate 3, 4. And the radius is on the other side. Okay, the radius isn't 49. The radius is whatever I square to make 49. So the radius is 7. You can square root 49 to find that, or you can just think, I know what number times itself is 49. Okay, so that's your worked example that'll help you get through the rest of the chapter. And I've just added one more slide to my notes since this wasn't attached to what I gave you and I probably wasn't really clear on it. Just do the whole chapter. It's not a very long chapter. There's only 2 or 3 questions in the preps. There's 2 or 3 questions in the pracs. All of the worked examples here will help you get through that chapter. It's not very long. Okay, so I reckon you guys can handle getting caught up with chapter 4.1 and 4.2 is really, really important. It's more important than this chapter. Make sure that you don't let those questions just go by the wayside. So make sure you're up to date with those questions first, and then get chapter 4.3 finished, and stay tuned for more learning, whether it's at school or not.